Hello everybody and welcome back, and in this tutorial we'll talk about the ARP spoofing. So since we are going to code in the next tutorial the ARP spoofer, which is basically used in order to intercept, it is the base of intercepting the connection between two different users on the same network. So for example, as I have a picture right here, let's say this is our Kali Linux machine, which is the MIT M connection. Now there are a bunch of tools that actually perform the ARP spoofing, but what we will be doing is we'll be coding our own tool. So the basics behind of this is that there is a packet called the ARP packet, which allows the users on the network, and by the users I mean the machines, to identify one another. So there are two types of the ARP packets. One of them is the request packet and one of them is the response packet. So in the request packet, some machine asks for the MAC address of a certain IP address. So for example, let's say this machine right here, let's call it machine R, which stands for router. We are A, which stands for the attacker, and this machine right here will be W, or pardon me, just V, which stands for victim. Or I could just do T for the target, but it doesn't even matter. For example, let's say this machine V, which is victim, asks for the MAC address of the router. So what this will do is it will send out the request saying something like this. So basically, what's the MAC address of the 192.168.1.1? For example, let's assume that this is the IP address of the actual router. Let me just write it right here. And what the victim machine will do is it will ask for the MAC address of this router. Now it will send out the request, and any machine that actually knows what the MAC address of this IP address right here is, which is the MAC address of the router, will send back the reply saying the MAC address of the 192.168.1.1 is at this MAC address. Then the victim PC will update its ARP tables with the MAC address of the router's IP. But what happens when we actually perform the ARP spoofing? Well, what does happen is in the normal connection, as you can see right here on the green line, the communication goes between the victim and the router in a straight line, because they are both identified correctly, and the router knows the MAC address of the victim and the victim knows the right MAC address of the router. But if we run our ARP spoofing attack, we can actually spoof both the victim and the router into thinking that we are one another. So for the victim, for example, we would send the packets that would say that we are the router, and to the router we would send the packets that would say we are the victim. So let me just draw it like this. And then, instead of the victim sending packets directly to the router, they would send packets to us, which we would then forward to the router. And then the router would perform forwarding further on, and then when they receive packets back which are meant for the victim, they would send those packets back to us. And that makes us to be a man in the middle by interfering their connection. Now we can do that for every PC on the local area network, so we can actually sniff some of the some of the passwords that are, for example, not encrypted and that are going through our own Kali Linux machine. For the first time, all we will be doing is just running a simple ARP spoofer. We will use the Scapy library in Python, which is a famous library for the actually configuring packets, sending packets, and bunch of the networking things we will be doing in that library. But for now on, in the next lecture, only thing we will do is just make a simple ARP spoofer. So this is just a little theory behind it, and I hope you understood it. If you didn't, don't worry, you can just post a question and I'll be more than happy to answer it. But this is rather simple. As it says right here, we are basically just a man in the middle interfering both of these people's connections. So that will be about it for this theory video. We will code the ARP spoofer in the next one, and then after that we will code some packet sniffers which will allow us to actually sniff some passwords that are going through from the victim PC to the router. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and in this tutorial we are going to look at a library in Python which is called Scapy. Now what Scapy allows us to do is actually configure our own packets and send them by our own needs. So we can send the packets, wait for a response back, we can print the response, we can do a bunch of other things, so we can basically manipulate with the packets that we actually send to the target. Now this helps us to understand better our ARP spoofer that we are going to code. So first of all, what we want to do is actually just check how the ARP packet is constructed to see its available fields and to actually change some of the fields and see what we can do with the ARP packet. But before we do any of that, I just want to introduce you to a certain command that you can run in both command prompt on Windows and in terminal in Linux. If you just type R -A, you get the ARP tables of this certain machine. As we can see, the ARP table is basically a table consisted of the IP addresses and the MAC addresses. Now what this allows our machines to do is to actually communicate with one another, since now my machine knows that the IP address of 192.168.1.1 is affiliated with this MAC address right here. So once it wants to communicate with the 192.168.1.1, it basically communicates with this MAC address. What ARP request allows us to do, which we will code just in a second, is it allows us to get the MAC address of a certain IP just by sending the ARP request. Then someone sends the ARP reply back and we get the MAC address of our target. So let's see how we can do that. Scapy, as I said, is a library by itself. We can just run Scapy instead of Python. And in order to do that, you just type Scapy. And this should open the Scapy interpreter, which allows us to construct our own packets. So we can see it has opened. It looks similar to the actual Python interpreter. And here, syntax is a little bit different. You can do a bunch of other stuff you can do in Python, but most of the stuff you can actually do. So first thing we want to do is see what actual fields does the ARP request have, or basically ARP packet. It doesn't have to be request, it can be reply also. And in order for us to actually do that, we need to type just ls, and in the brackets, ARP, type ARP, close the brackets, and it will print out the available fields that the ARP packet has. As we can see, the P destination is the IP field of a target we want to actually get the MAC address from. The hardware destination is the MAC field of the target, which the hardware address or MAC address we want to get. The P source and hardware source is basically our IP field and MAC field. The OP is basically the type of packet we want to send. The 1 stands for the request and the 2 stands for the reply. So you can send this OP value to be either 1 if you want to send an ARP request or 2 if you wanted to send the ARP reply. So let's see how we can actually construct a packet in order to get the same MAC address from this command from our router. So the IP address of router is 192.168.1.1, and we want to get the IP address or the MAC address of that router. Let's pretend we do not know it. So in order to do that, what we can do is first of all create a broadcast packet. So in order to do that, you just need to press equal ether. And in that broadcast packet, since we will concat it to the ARP packet, we want to select that we are actually sending this packet to the broadcast MAC address. Now, what the broadcast MAC address is the MAC address where actually every machine on our local area network will receive this packet, and if some machine knows the answer to our question, it will respond back. In order to select to a broadcast MAC address, we need to select the DST field right here to be equal to this MAC address. So just select it like this, equals to FF, and once again FF. This is the MAC address of the broadcast, this is the broadcast MAC address which we are going to send the packet to, so just click enter right here. And since we created the broadcast packet, all we want to do right now is also create the ARP packet. So in order to do that, you just make ARP packet, for example. Let's call the packet like that. We set it to be equal to the ARP, so just type capital ARP, open and close the brackets, and let's say we want to actually set the, let's actually see what we want to set in this ARP packet. So we want to set the P destination field to be the IP address of our router, since it's the router's MAC address we are looking for. So in order to do that, you just need to select this field right here, copy the name of it, paste it right here, and type equals, and there you can actually set it to be the 192.168.1.1. which is the IP address of our router. Press here enter, and you successfully constructed the ARP packet, which has this value under the field of P destination. In order to check it, you can just type ARP packet.show with open and close brackets, and there you will have all the things that this ARP packet has specified. Now, as you can see, some of these things are specified by default, such as the HW source and the P source, which is our MAC and IP address, which basically is set by default, since the Scapy can recognize what our IP address is and can see what our MAC address is. Now, if this for some reason doesn't specify for itself, you can check both of your MAC and IP address by just typing ifconfig in your terminal. As we can see, my IP address is 192.168.1.7, which is selected under the P source field. My MAC address is this MAC address, which is selected under the hardware source field. So let me just, in case you are not seeing this very well, let me just zoom it like this. Then I will move this a little bit to the side, just like this. Move this all the way down. Just make it a little bit prettier. Okay, so it's good right now. And we can see that all we actually have to do right now is concat these two packets. since we are looking for the actual MAC address of the router, we want to send our request to the broadcast MAC address so all PCs or all machines on the network can receive it. In order to make these two packets into one packet, we can just do the final packet, so let's call it final packet, equals, and all we have to do is just make a simple statement that looks like a division in Python, so broadcast, and then the /ARP packet. So we created our final packet, which we are going to send right now. So in order to check the fields of your final packet, you can just type final packet.show, same as the ARP packet. And you can see that our final packet has the Ethernet field, and under the Ethernet field, it has the ARP field right here. This source is our MAC address, this destination is the MAC address of the actual broadcast, and this right here, the type, is the type of packet that we have under our final packet, which is the ARP packet. So 0x86, basically, or pardon me, 806 stands for the ARP packet. So all we have to do right now is send this packet to the target, or basically to the broadcast MAC address, and wait for a reply back, which then we will store in a certain variable, which we can print afterwards. So let us call that variable answer, since the answer is what we are looking for after sending this packet. And in order to send it, we can just type srp, and in the brackets, we need to specify which packet are we going to send. So we are sending, of course, the final packet, since that is the packet that actually consists of both the Ethernet and ARP field. We can set the timeout to be equal to 2 seconds. And we can set the verbose to be equal to true. So we can see what actual, oops, let me just check this out. What actual things is this performing? Since this answer will actually return a list, and the list consists of the answered and unanswered, basically, responses, we want to select only answered, so we will select the first list, which will be under the value 0. So click here, enter. As we can see, finished sending 1 packet, received 1 packet, got 1 answers, remaining 0 packets. So someone sent our answer back. In order to print that answer, we can just use the actual, let me just show you, we can store it in the variable, which we can call MAC address, which will be the MAC address of our target, which we want to get under this field, which is the hardware destination. And all we want to do is select the answer, or let me, before I do that, just show you, if I just type here answer, you can see that the results is under the other. So what we want to do is select a certain, let me just show you, if you just type MAC address equals, and then answer, we take the first argument and the second argument of that list, and the field that we want to actually get is the HWDST, which is the hardware destination. So all we have to do is press dot afterwards and type HWDST. So just press here enter, and now our MAC address is stored in the MAC address variable. So we can just print MAC underscore address, and you can see that right now we got the MAC address of, let me just check this out. Why did we get our own MAC address? That is a really good question. Well, for some reason, maybe I selected something wrong, but for some reason, oh, pardon me, we are not looking for the actual, or we are actually looking for the hardware destination. And what did I actually select right here? Let me just double check everything in order to see if I selected it correctly. Let's print the MAC address. Okay, so hardware source, of course, I was confused a little bit because I selected right here the hardware destination as to the actual field where the router's MAC address will be, but the hardware destination is actually our own MAC address. And now you might be asking, why is that, since here it is the hardware source, which is our own MAC address? Well, this that we sent is a request, and the value that we are printing is the value from the response which was sent from the router. So basically, the router's packet is having these two fields flipped as to us, so the hardware destination will be our MAC address and the hardware source will be the router's MAC address, since the router is the one that is sending this packet back. And we can see that the router's actual MAC address is this one. So that would be basically it on how to actually get the MAC address from a target. Now, in order to actually create a malformed packet, what we can do is actually craft a packet which will specify wrong thing. Now, by wrong thing, I mean that we can actually fool our Windows 10 PC into thinking that the MAC address of the router is our MAC address. Then what our Windows 10 PC will do is it will send all the packets back to us. And since we haven't anything else specified, the actual Windows 10 PC will lose its connection to the internet. So let us see how we can create a malformed packet. So let me just see if I can, what we can do is actually make a variable called packet. And this variable packet will be an ARP packet, which we will then send. And what we want to do is, since the first packet we actually sent was a request packet, which was under the OP and equal 1. What we want to do is make OP equal 2, since right now what we are sending is the actual response. We want to send the response to the Windows 10, even though they never sent us our request. We want to send them a response saying that we are the router. So we can do that with OP equals 2, which is the actual response. The hardware destination is equal to the actual MAC address of our Windows 10 PC, which we can actually get since we don't actually have. So let us see how we can get it. We can make our final packet .show. We can just change a little bit of code in our final packet. So in order to do that, we need to change the final packet dot, let me just check it right here. I believe it is the the P destination has to be equal to the IP address of my actual Windows 10 PC. So let me just check it out. It is 192.168.1.5. So we select 192.168.1.5, whoops, not 6, 5, instead of the router's IP address. And all we have to do is actually just use the same command from before. Final packet, timeout. We want to send the, oops. Wait, let me just check this. Don't actually execute these two commands. My keyboard actually, not really sure why it did it, but we can just ignore these two commands, and we want to send this final packet once again. So in order to send it, we use the same thing as before. So we will use a variable answer again, and that answer we will send the packet. So we can use the final packet to send it. Timeout will be equal once again to seconds, just in case. We can use the both to be false right now. It doesn't really have to be true. And we use the first list answer right now. So we see if it got answer. It got answer under the section other. And all we want to do is actually set the MAC to be equal to the answer. We select the first value, open square brackets 1, and we want the hardware source. And we want to actually print MAC right now. So this is the MAC address of my Windows 10 PC. And right now we can actually send the malware packet to my Windows 10 PC. So let me just run ARP-8 in my Windows 10 just to see once again what the actual MAC address of the router is. So the MAC address of the router is this, and now we will change it to be this, since this is the MAC address of my Kali Linux machine. So let us see how we can do that. We will select a packet variable to be equal to ARP packet OP2 once again, since we are sending the response. The hardware destination, so hardware destination will be equal to the MAC address of our Windows 10 PC. So let's copy it, select it under the double quotes, paste it right here. And then all we have to specify again is the actual P destination, so the IP address of our Windows 10 PC, which will be the 192.168.1.5. And here, what we want to select is the P source. So P source, not really sure. Let me just move this to the side so you can see it a little bit better. So P source equals the IP address of the router actually. So what we want to select is that our source IP address is actually 192.168.1.1, which will then trigger the actual, where is my actual packet going? Okay, so here it is, which then will actually trick the router into thinking, I'm not really sure what is happening with my actual terminal, but it doesn't really matter. What I just added at the end of this command is the actual bracket, which for some reason added up right here, but it doesn't even matter. Right now, we need to send this packet in order to trick our Windows 10 PC into thinking we are the router. So how we can send? We can just use send and then packet, since that is the name of our packet. We can send the verbose to be false, since we don't need it. And we just send the packet. And right now, if I just type ARP-A once again, you can see that right now the the MAC address of the router has changed. So we successfully changed the ARP table in our Windows 10 PC into thinking that we are the router. As you can see, the IP address of my Kali Linux machine and the IP address of the router both have the same MAC addresses, which shouldn't be like that. So we successfully ARP spoofed our Windows 10 machine with one packet. We crafted the packet and then we sent it to the target. What we will do in the next video is we will actually make a program that will do this in a while loop, so we can actually spoof the Windows 10 PC as much as we want, and also we need to spoof the router as well. So we need to spoof two targets in order to make this actually work, since only spoofing the Windows 10 machine will not do us any good, since the router still knows that the MAC address of the Windows 10 PC is its true MAC address, and we want to spoof the router as well, so the router sends packets back to us. So we will see how we can do that in the next video. Hope you enjoyed this little demonstration. Not really sure what happened with my terminal right here, but everything finished well. Hope you enjoyed it, and I hope I see you in the next video. Bye! Hello everybody, and welcome back to this tutorial. And right now, let us code our ARP spoofer, which will spoof the router and the actual target, which will be on our Windows 10 PC, in a while true loop. So right now, let me just see, go to my Python programs, go to scanning, or pardon me, not scanning, go to local area or local network programs. Here we have our MAC change from the previous videos, and we want to nano ARP spoofer, spoofer.py. So press enter right here, enter our usual user bin Python line, and we want to import the actual Scapy library, and we can do that with the import scapy.all as Scapy. So this is the way that we actually want to import it, so we can use an easier syntax. And for now on, that is all we want to import. So what we are going to do in a main function, so let me just add it right here, main function. We call it right there, and then we will code it right here. And all we want to do is actually try and accept to spoof. And accept, to spoof the target. So we will run an actual function, which we will call spoof_arp, and there we will specify the IP addresses, and we need to run it twice since we are actually running spoof_arp, since we are actually running the two different spoofs, which one will be for our router and one will be for our Windows 10 PC. And also what we want to do is actually try this in a while true loop. What this will actually mean, let me just show you, is that we are going to run this as long as we don't interrupt with our keyboard. So we'll just code it like this. Let me just add a little bit space so this looks a little bit prettier. And let's see what we want to actually paste to our spoof ARP. We can't really paste the MAC addresses since we don't know the MAC addresses of our targets, but we do know is the IP addresses. So we know that the IP address of my Windows 10 PC is .1.5 and the IP address of my actual router is .1.1. So let us specify the two arguments for both of these functions to be the IP addresses of the router and also the IP addresses of the Windows 10. So we can do that with the 192.168.1.1, comma 192.168.1.5. We now do the same right here, but we will do this in a different order. So first we will specify the IP address of the Windows 10, and then we will specify the IP address of the router, since we are spoofing different targets with this. So since we made our spoof function, what we want to do is actually code the function right here. So let us code it with the spoof arp. We need to set def right here, and we need to paste the arguments, which will be, the first argument will be the target IP that we actually want to target. So in the first case, that will be the router, and the second argument, which will be the IP address that we actually want to fake. So the target IP underscore IP and the spoofed IP underscore IP will be our two arguments right here. The spoofed IP basically means that the IP address that we are going to pretend to be while sending the packets to the target IP address. So in order to actually be able to do all of that, what we need to do is actually get the MAC address of our target. So in order to get the MAC address of our target, we will select the MAC to be equal get target MAC from the target IP. Now this function doesn't exist, of course, so we have to code it we named it def get target IP, so we will name it the same right here, or not IP, MAC, and as an input it will take the IP address. Since we specified right here that we want to select an input of the actual IP of our target, and all we need to do right now is actually specify the same process that we did in the previous video, which will get us the MAC address of the actual target. So we can select the ARP request, for example, since we are sending the request to be equal to the scapy.arp. We need to select the p destination, which is the destination of our target, to be equal to the IP of that target. And we also need to select a broadcast packet, which will actually be the ether packet, which will contain the MAC address of the broadcast, or basically which will contain the broadcast MAC address. So we will do the same as in the previous video, ff, and once again ff, close the quotes, and all we have to do is concat these actual packets to a final packet, equals broadcast /ARP underscore request. So let us recap. What we are doing is we are creating a request that will actually contain in the p destination field the IP address of our target. Now all of the other fields we don't have to actually select, since they are, as we saw in the previous video, automatically selected by the ARP, by this KP itself. We created a broadcast packet that will actually that actually has a field of the broadcast MAC address. This means that it will send to any machine on the local area network, and we used both of those packets to make it a one big packet, which we called final packet. So all we have to do is actually type right here that the answer, so we will do the same as before, equals kp.srp, which stands for basically sending and receiving the answer. We want to send the final packet. Let's select the timeout for this packet to be equal to 2 seconds, just in case. And all we want to do is select the verbose to be false, since we don't really need to actually look at it, and that it doesn't really provide any useful information to us. And we want to select the first list, which will be the list of our answers. We don't care about the second list, that's why we only use the first part of the list that we receive from the actual response. Now all we want to do is actually select right here that the MAC equals the answer. We select the first part, then the second part, and we want to select the hardware source, which, if you remember in the previous video, I made a mistake. I, for example, specified the hardware destination, and I was confused why we actually got our Kali Linux MAC address. But right now, since this is a different packet, this is a response that we are getting, we need to specify the hardware source, since this is the source of the target that is sending us back the response. You just see, so software update not now. And all we want to do right now is return from this function with our MAC variable, which has the actual MAC address of our target. So then we will specify the MAC address right here, as we have it right there. And all we want to do is actually send the packet. So we will call that packet, which will be spoof packet. We want to select it to be an ARP packet, so you can do that with kp.arp. Now you might notice that in the previous video we only used the ARP, we didn't have this kp prefix. Now since we are using this as a Python program and we imported it as a library, as kp, we need to use this kp prefix in every function that we use from this kp library. So let's code this packet. We want it to be a response, which we can select with the OP field equals to the hardware destination, with the actual is the actual MAC address of our target that we are spoofing, which we got from the getTargetMAC function. So we will just paste it to be equal to MAC, since our variable returned the MAC address from that target. The p destination is the actual destination of our target, so we can just select the target underscore IP. And the p source will be the source or the IP address of the machine that we want to actually fake, which is the actual spoofed IP. So in this case, we are sending the ARP request, the ARP replies to the router, pretending that we are Windows 10. So all we have to do right now is, since we created our packet, all we have to do is actually send this packet to the router. So we can use the functions kp.send. We send the packet and we set the verbose to be equal to false. False. So close the actual brackets, and basically this is it. This is our entire ARP spoofer. As we can see right here, we are both spoofing the ARP tables of the router and the ARP tables of our Windows 10 PC. So let us see how this will actually work. So let me just save this. Before I do any of that, let me check the MAC address of the router in ARP-A with the ARP-A command, so ARP-A. we can see that it is all good for now. 192.168.1.1 is set to be at this MAC address, which is 04 minus CEO, and so on and so on. So with this program, we should be able to change that for as long as we want. So we have our ARP spoofer. Let's make it an actual executable. And let's run it with Python 3. We let this run. Expected and intended block. So let us see what is wrong with our code. We nano it. Okay, so we didn't code anything in the keyboard interrupt part. So we can just try right here to code the actual exit the program. So let us try right now. No module named scapy.all. So let us see why doesn't it have scapy.all. Let's actually go to the Python 3 in order to see how we need to import the scapy. So import scapy. From scapy.all import scapy. We see if Python 2 has it. So import scapy. So Python 2 actually has it. So let's actually try to run it with the Python 2. We are running our ARP spoofer with Python 2 right now. And if I just go right here and run the ARP-A once again. Okay, so we are still... Okay, so right now, as you can see, we saw the live moment where it actually changed to the MAC address of our Kali Linux machine. So our ARP spoofer is working. We are successfully actually spoofing the target. As we can see that the MAC address of my Kali Linux machine and the MAC address of the router are both the same on our Windows 10 ARP tables. We can see if we run it once again, it will remain to be the spoofed MAC address as long as we are running this program. And since we are not actually forwarding the packets between each other, you can see if I go on my internet, so let me just click on the Google Chrome. And if I actually try to open a page, any page, it will not connect to the internet. So we can actually try to go to the facebook.com. We press enter in order to try to actually load the page. You can see it is not loading it. It will not load the page fully. As you can see right here, I lost my connection. I get the error that there is no internet. So this actual program, in case you're not forwarding the packets, can actually make a DOS attack on the entire local network. So nobody on the local network, if you were to example spoof multiple targets, will be able to actually connect back to the internet. So let's see in the next video how we can actually make the packets go from our Kali Linux machine to the router and Windows 10 PC, so we don't actually kick everyone off the internet, but we will see that in the next video, as well as actually fixing our program with a few different things. So hope you enjoyed this video, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to the second tutorial of actually coding our ARP spoofer. And let us see what we can do in order to fix a few things with our program, such as actually forwarding the packets as we run the ARP spoofer. So let us nano our ARP spoofer.py. Here is our program, which we coded in the next video. And let's actually code a function that will restore both the IP address, the MAC addresses in the ARP tables of Windows 10 and in the ARP tables of our router. Since as soon as we finish making our program or running our program, we want to actually restore everything back to normal, so the target PC and the router doesn't actually lose the connection. So in order to do that, we can make a function which will basically restore everything. We will call it restore. In that function, what we actually want to have is the IP address of our target and the IP address of our router. So we will just set it right here. Destination underscore IP and the source underscore IP. So we make this function right here. All we want to select right here is actually getting the real MAC addresses from our targets. So we want to actually get target MAC from the destination IP, which is the IP of our router in the first case, and the IP of our Windows 10 in the second case. And we want to do that for the both machines. So let me just show you how we can do that. We get MAC or get target MAC from the destination underscore IP. We will actually put that into our target MAC address, since this will be the real MAC address of our target, and the source MAC address will be the source MAC address of the actual router in the second case. So get target MAC source underscore IP. all we want to do right now is actually send the packets with these two values. So packet equals skp.send. Pardon me, not skp.send. We first of all need to create the packet before we actually run it. We only created the MAC addresses. So open and close this. We make sure that it is a response. We select the p destination to be equal to the destination of the router's IP. The hardware destination equals the target MAC variable that we got with our get target MAC function. And the p source equals to the actual source IP, underscore IP, as well as the hardware source equals to the source MAC. And all we want to do right now is actually skp.send this packet. So we want to send this packet, and we want to set, as usual, both equals false. So all we have to do right now is, as soon as we actually close our program, we want to run the restore function on these two MAC IP addresses. So we run it on both our Windows 10 and on both the routers, so restore also the Windows 10 machine. We need to perform 2 times this function for each of the machines, and then we can actually exit the program. So everything should be good to go. Let me just double check everything. Now, in order, if you actually wanted to target multiple machines, you can just put this in, for example, for I in range 1 to 255, you can just make this, instead of the 1 to be, for example, the plus string of I, or something like that. You can just put it in an actual loop in order to actually spoof multiple targets, but we won't be really doing that right now. All we want to do is actually see how the ARP spoofer works, and in order to understand the process behind this a lot better than before. So everything should be good to go. All I have to show you right now is actually how to forward the packets once you start ARP spoofing. As you saw in the previous video, we weren't really able to connect to the internet. So let us save this, save it in with Control O. And in order to forward the packets, there is a file. Let me just remember how it is called. Okay, so the file was cat proc sys, the net. Let me just see. So we want to go IPv4, IPv forward. Okay, so that is the file. Let me just clear the screen. So if you cat the proc sys net IPv4 and then IP forward, you get this 0 in that file, which means we are not forwarding the packets. But if you echo into that file, so let me just show you, if you just write echo 1 and then the arrow to right, if you press enter on this path and you cat it once again, right now we have 1 in that file, which means we are forwarding the packets. So if we run our ARP spoofer once again with the arpspoofer.py, everything is running smoothly. Now, first of all, before we go to the internet, let us try to run the arp-a in order to see if we successfully spoofed the MAC address. As you can see, we still didn't, but if I run once again, right now the MAC address is spoofed. And right now, in the previous video, as you saw, we weren't able to access the internet, but if we click right here once again, we open the Google Chrome from our target PC. We, for example, want to run the twitter.com. All the packets will go to our Kali Linux machine, and we will be able to load the page, and we will not know anything that is going on around us. We will not know that our packets are being sniffed at, or not sniffed at yet, but being ARP spoofed, and that are going through a whole different machine before actually reaching the router itself. So we actually got the response. The only way for us to actually check that out, if we are being ARP spoofed, is to run the arp-a command, and to see that we have an MAC address right here, which shouldn't be there. As you can see, the first alarm would be that we actually have 2 IP addresses that have the same MAC address, which isn't really possible. So that would be the first way for you to find out how that you are actually being ARP spoofed. So that would be about it for this video. We successfully coded our ARP spoofer, but before we actually close this video, let me see if I just press Ctrl+C and open my command prompt once again. Let's see if our router MAC address actually returned back to normal. And as we can see, it did. So the MAC address returned back to normal. So once we actually start running this program, the target will not notice anything, since we actually made a restore function, which will restore back the true MAC addresses of the target and of the router. So that will be about it for the ARP spoofer. We will continue coding in the next lecture. Hope you enjoyed this video, and I hope I see you in the next tutorial. Bye! Hello everybody, and welcome back. And in this tutorial, let us see an idea behind the actual SYN-flood attack. Now, the SYN-flood attack is basically just sending the TCP packets to the target, spamming it with a bunch of packets, and then basically making an over-connection to each port and make the target not being able to actually run any software on open ports or connect to the internet as well. So let's see how we can do that. What basically SYN-flood is, as I said, we will just be sending a bunch of TCP packets to the target. Now, this will not be enough to actually crash the target since you're sending this from one PC, but if you, for example, have a botnet, which we'll see in the future lectures how we can actually create a command and control center with the multiple PCs connecting back to us, and then you can upload the software to each one of them and run the actual attack. But for now on, let us see the simple code behind it. So first of all, what we can do is, first of all, open Scapy. And what we can do with Scapy is actually see what the actual power of Scapy is. So let us create a simple packet. So the packet will actually have two layers. One will be the IP layer. So let us select the IP layer to equal the IP packet. For now on, we will not select any options. All we want to do is just print the IP layer. Or not like that. We want to actually add .show in order to see the fields of the IP layer. So with the IP layer, what we will do is we will actually concat the TCP packet to this IP packet. So we also want to add the TCP layer equals TCP. We open and close the actual brackets, we don't specify anything, and in order to put these two packets into one packet, we need to make, for example, a packet variable, and that packet variable will be equal to IP layer slash TCP layer. And then if you just print packet.show, we can see all the fields from our packet. So in order to actually send this to someone, you can see a few fields that we actually need to change. That would be the source field and the destination field. Now, the good thing about this is that the source field, which will be our IP address, of course, and the destination field, which will be the target's IP address, don't even have to be true. Now, the destination IP address has to be true in order for this packet to go to the right destination, but the source field, we can select our IP address to be anything we want, and target, while scanning it with Wireshark, will see a fake IP address. So let's see how we can do that. First of all, let me run Wireshark from my Windows 10 PC, which we will be attacking. So if I run Wireshark right here, basically Wireshark is a program for sniffing packets. We can not intercept, we can actually view the packets and their fields in the Wireshark as they flow on our network interface. So let me just show you. First of all, let's wait for the Wireshark to actually open. And then what we will do is we will send this packet with, first of all, the true source and the destination IP. And then we will try to fake the source IP and see if our Windows 10 machine will see the IP address of our Kali Linux machine, or will it see the IP address that we actually faked. So our Wireshark has opened. If you don't have Wireshark, don't worry, it is basically pre-installed in Kali Linux. You can just type Wireshark in terminal and this will open. You don't need to run it in Windows 10. But in case you are running it in Kali Linux, you need to specify the target to be your Kali Linux machine, which you can easily specify just by selecting the source and the target to be the same IP address. So you're basically sending packets from you to yourself, in case you don't have the Wireshark on any other PC. Or if you want to actually do the same attack right here, you can just download Wireshark. It is not really that hard. And then you can perform this and inspect the packets that we're going to send. So let's wait for this to load. It is a little bit slow because I'm running bunch of things such as the actual virtual machine. And while it's actually opening, what we can do is select the source field and the destination field. So the packet.source field we can select to be the IP address of our Kali Linux machine, which is 192.168.1.7, and the packet.destination field can be equal to the IP address of our Windows 10 machine, since we are attacking Windows 10, so 168.1.5. And if we inspect our packet once again in order to see if the actual things that we specified are correctly specified, so they are right here. Let me just see if this is opened. Okay, so we got some window prompted. Let me see what this window is. It is some update. We don't need an update right now. but it doesn't want to close, doesn't even matter. And you select the interface that you are sniffing packets on, which in my case will be the Ethernet interface. In order to only filter out some of the packets, you can just type right here TCP packets, for example. Or it is lowercase TCP. You press the blue arrow right here, and right now you will be seeing only the TCP packets. So let's see what happens once we actually send this packet. So in order to send the packet, we can just use the send, and in the brackets we specify what we want to send. We are sending the actual packet. If we go back right here, we stop this, and right now what we want to do is actually try to find our packet that we sent. So if we find it right here, you are looking at the source and the destination. Remember that the source we specified to be the Kali Linux machine, and the destination is the IP address of this Windows 10 machine, which is running the Wireshark. And we can see that our received the packet from the Kali Linux machine, which is 192.168.1.7, and we can see that the actual source field is the good IP address. So this is the packet that we send with our SCPI. So there are a few things that you can actually modify into sending malware packets or so on and so on. As you can see right here, if I go back to my packet and I add a load to be equal, well, I'm not sure if I need to specify brackets, to be equal to hello string, or maybe it is packet.raw.load. Not really sure. Let me just remember what the actual syntax is for this. So let's see, packet.show. Okay, so yeah, we need to add another layer, which will be the raw layer, I believe. So packet will equal, or another packet, so packet2 can equal raw. Good, so, and all we have to do is make our packet to be equal to the previous packet, and then slash packet2. So right now what we have is also a raw layer. If I just print it like this, so packet.show, you can see we have a raw layer that is concatenated to the TCP packet, which is concatenated to the IP packet. And what we can specify in the raw layer is this load field. And in order to do that, we can just type packet.load equals, between the double quotes, hello, this is a secret message. We close the double quotes, and we send the packet once again. But before we send the packet, we need to start actually scanning for the packets once again. We do not want to save this. We only filter the TCP packets, and we send this packet. We sent one packet, so we can now stop this. We want to find the actual IP address of our Kali Linux machine, so it is .1.7. Let us try to find it. It is not here. Let's go a little bit up. Okay, so here it is. This is the packet that we sent. If I go right here, and you go to the transmission control protocol, let me just go right here. You go to the TCP payload, click on that. You can see the TCP payload is 30 bytes, and you can see that we actually send, hello, this is a secret message to our Windows 10 PC. We actually send some data to our Windows 10 PC with our SCPI library. Now let's see how we can actually fake the actual IP address of our Kali Linux machine. So we can do that just by changing this source field right here. So if I just type packet.source equals, for example, let's use the Google IP address, which is 8888. We send that. We start intercepting for packets in our Wireshark. Continue without saving. We only scan for TCP packets. We go back here and we send the packet. We go back right here. We close this. And we can see our packet is right here. And in the Windows 10, it pretends that it is a Google server, which it really isn't. We just changed our packet source IP address to be the 8.8.8.8. And it still has the hello, this is a secret message that we encoded into our TCP payload. And as we can see, the Windows 10 has no other way into actually finding out who actually sent this packet. As we can see all the other fields, the actual Internet Protocol field, let us find it right here, since there should be the source IP address, and we can see that under source IP address is the actual 8.8.8.8. So it really does seem that this packet came from the Google DNS servers, which it really didn't. Now in order to create the SYN flood, which I talked about, all you have to do is create a packet. So let us go to our Python programs, go to our local network programs, and nano SYN flood.py. And there all you have to do is add this line user bin Python from scapy.all import all. You can just import, or pardon me, not all, we want to import. We can actually import everything with this star right here, so hopefully something like this will work. We can check it out. And all you have to do right here is actually make a synfloat in order to, or basically create a packet and run it with a while loop or while true loop, and it will send the packets forever to each port. Now we will be doing that in the next lecture, so we don't make this one too long. So I hope I see you in the next lecture where we'll actually code a synfloat program. It is rather short, so don't worry. I hope I see you there, and take care. Bye.